When we graph the sine and the cosine curve, we start from the unit circle. Was here. Sine of 0, pi over 2, pi, 3 pi over 2, and back to 2 pi. So let me write those in again real quick. Pi, that way we can graph them. Pi 0, 3 pi over 2 is -1, and 2 pi. That way you have them. So what we're going to do is we're going to plot this. Now, on the x-axis, we have the angles, and on the y-axis, we have the sine value. So this is theta, and this is sine of theta. I think that's important to understand. So for the first point, we have a theta of 0 and a sine value of 0. So we're going to put a little dot there. For the next value, we have pi over 2, 1, then pi 0, then 3 pi over 2, -1, and 2 pi 0. So what we'll do is connect those nicely. I'm sure that I could have done a better job on that. But you can see that it looks like that, like an S that's been turned and flipped on its side. And what's going to happen is the more that we continue to rotate around the unit circle in either direction, you're going to have more and more rotations of sine. And so this will keep going on forever. So the domain will be all the real numbers, all the thetas of any rotation. Now the maximum y value, if you look here, it tops out at 1, and the minimum y value at -1. So the range, or the y values, range from -1 to 1 using interval notation, and that is everything in between. So we have all these values of y in between. It says that sine is a periodic function because its y values repeat, and the period, which is the amount of time that it needs to finish one full rotation, is 2 pi. And that shouldn't surprise you because one time around the unit circle is 2 pi. Sine is an odd function, which means it has symmetry with respect to the origin. The x-intercepts are 0, pi, and 2 pi. That's where it crosses the x-axis. And the y-intercept, the only y-intercept that we have, we can say pi. I'm sorry. The only y-intercept that we have, is where it crosses at the origin, or 0. Y equals 0. All right, so let's do this for cosine. Let's take a look at the cosine values. We have 1, 0, -1, 0, and back to 1. So at 0, we have 1. At pi over 2, we have 0. At pi, we have -1. At 3 pi over 2, we have 0. And at 2 pi, cosine is back to where it started at 1. I'll circle that. Now cosine starts a little differently. It does not start at the origin. You can see that it starts at the point 0, 1. And then it travels to pi over 2, 0. Pi is at -1. 3 pi over 2 is at 0. And 2 pi is back to where we started. So a lot of people like to draw this as a V, but it really is a curvy function. And it will keep doing that on and on forever. So it really looks kind of like that. Not a beautiful sketch, but that's what it looks like. The difference between cosine and sine is one of them is that the starting point is not at the origin. The domain is the same though, because this can get rotated around the unit circle infinitely many times in any direction. The maximum y value is again 1, and the minimum y value is the same. It's -1, same as sine. The range is the same from -1, everything in between, all the way up to 1. Now cosine is also periodic because its y values repeat. And again, its period is 2 pi. Cosine is actually an even function because it's symmetric with respect to the y-axis. If I draw a little line of symmetry down through the middle of it, you can see that it's symmetric in the y direction. Let's see, the x-intercepts are going to be pi over 2 and 3 pi over 2. That's where it crosses the x-axis. And the y-intercept is going to be at 1 right here. So that's what cosine looks like. Now let's talk a little bit more about how these graphs can be transformed. Because they're periodic, what we have graphed here is just the parent function. Obviously, it's not going to look that way all the time. There can be changes made to the graph and transformations where we can slide it by translating it. We can, how do we want to say, we can stretch it either vertically or horizontally. You can do all kinds of transformations to it. Today we're just going to explore a couple. The first one is amplitude, and I will let you read here. I'm not going to read it to you, but the thing that I want to emphasize is that amplitude is an absolute value. So the basic standard form of a sinusoidal function looks like this. The A is the amplitude. That's basically talking about its height. Normally it goes from 1 to -1. But if you multiply it by another number out in front, for example 3, then the maximum of the graph will be 3 and the minimum will be -3. So it's a multiplier. Now if you have a negative A, let's say you have something like y equals -2 sine x. Your amplitude is still 2, but what the negative sign does is it's a reflection. And this isn't new. We know that a negative sign out in front is a reflection over the x-axis. So we'd have to reflect that when we do the actual graph. One of the other things that we can vary from the parent function is the period. Typically, the period of sine and cosine is 2 pi. But what if your b value is not 1? What if it's 2 or 3 or 4? That means you're subdividing. You're taking that 2 pi and you're dividing it into however many iterations of the sine curve that the equation reflects. So let's say, for example, you had 2 sine of 3x. Well, this would be your amplitude. And this would be what we call your frequency. This is how many. Frequency is how many. So we would have to take that frequency and divide it by the how many, by 3. And so each one would now have a period of 2 pi over 3. We're just subdividing. So looking at a couple examples, remember we have y equals a, either sine or cosine, times bx plus c plus d. We'll get into c and d another day. We're not going to do that today. We're only going to talk about the amplitude and the frequency and how it relates to the period. So here our amplitude is 2, and our frequency is the coefficient on the x. I'm going to put a little 1 here. So our period hasn't changed. When we do 2 pi over b, that's 2 pi over 1, or just 2 pi. So anytime you just see the x by itself, the period is normal. It's just a 2 pi. Here in the next example, your amplitude is a positive 3. Now I know there's a negative sign on that. That negative, remember, means reflection over the x-axis. So your amplitude is not negative 3. It is always positive. Now your frequency. Here's your frequency. That's your b value. When we do 2 pi over 4, that's pi over 2 when we reduce a fraction. So each one is going to be pi over 2 for the period. Because if we add up all 4 of those, we would get back to 2 pi. And lastly, here we have an amplitude of 1/2, which means it's going to be a little shorter. Our frequency is also 2 pi. So when we divide that out, we're getting a period of 1. And pi is not in the equation anymore. That's 1 radian, just so you know. And that means the whole 1 cosine curve would take 1 radian to do that. So if we look at this one, 2 cosine x, remember that cosine looks like that. So that means it's going to start at 0, 2 instead of 0, 1. And it's going to go down. Oops, I messed that one up. Let me get my eraser. Oops, didn't get the eraser. There we go. Our min is also going to be at negative 2. And the amplitude are not too bad here. The period is just 2 pi because the b, or the frequency, is 1. So when we do 2 pi over b, we get 2 pi over 1, which is just 2 pi. So this is going to look a lot like the other one that we did, only it's just going to be taller, like that. Example 2 does not have a multiplier out in front. So that means that the amplitude is 1. So that means we're doing this for the starting point. Now, the frequency is different. The b is 1/2. So when we do 2 pi over b, 2 divided by 1/2 is like saying 2 times 2. And that means that this thing is going to be stretched out all the way to 4 pi. Which means here's where you're going to get your negative 1. That's the halfway point, and that's where you're going to end. And it's not going to be pretty. I'm just saying. Went up a little high there. But that's what the cosine curve looks like when it's all stretched out from left to right. We will be doing more of these for sure, but these are just an introduction to get you used to what the parent functions look like and a few of the transformations.